Want to know how tomorrow's technology will be managed? Then stay tuned because today you'll learn everything you need to know about smart grids and how they've evolved from a simple system to one that will undoubtedly reach everywhere in some form. This is a topic that needs to be understood in depth. Smart grids are an evolution of traditional electrical grids, but with different elements that improve the system, bringing advanced technology that allows the automation of energy distribution. In other words, it's a way of transmitting electricity to us. So, how do they differ from traditional power grids? Well, it's quite simple. Smart grids allow for a two-way flow of information and electricity. In simpler terms, they don't just transmit energy from a power plant, whether hydroelectric, nuclear, or otherwise, directly to homes, businesses, or users. No, they also send real-time data about consumption and the status of the grid. It's like the internet, but for electricity, with greater efficiency and the ability to automatically integrate renewables. One thing is clear, the world needs a change right now, and we are in an era of severe pollution. Science has been working for years on new, less harmful systems. And with the increasing demand for energy and the need to reduce carbon emissions, smart grids are a solution to manage electricity distribution more efficiently and sustainably. Let's take a closer look at what they are and how they benefit us. First, let's look at their internal makeup. Starting with the basics, we'll understand a little more about how they generally work, how they benefit us, and how they help us in the long run. Smart meters. These record energy consumption at short intervals and also send this information to service providers in real time. Sensors. These are used to monitor certain internal aspects of the grid, whether it's parameters, flow, or even things like weather conditions, and most importantly, equipment status. Communication networks. This is the system that allows for the transmission of data between the various components mentioned above. It's, shall we say, the hub that controls everything and ensures that information is shared quickly and efficiently. Advanced control system. This is the operating system or software of all the above components, responsible for gathering information and making decisions to optimize power distribution, detect faults, and manage demand. There is an unpopular myth that the system is designed to control our electricity connection, shut it off whenever they want, regulate it, or worse, know what we're doing all the time. But nothing could be further from the truth. There are thousands of methods, and this will be the least of them. In reality, these methods are for energy saving and conservation, to prevent electrical waste. Among the things that can be done are optimizing power distribution. Real-time data is used to adjust power distribution according to household demand to better control losses. Reducing energy losses. With the detection and correction system, internal power problems in any home can be found and quickly resolved. Or if not possible, the energy reaching that area can be restricted and repairs initiated, minimizing energy losses. Real-time monitoring and management. Little is said about this aspect of monitoring. Thanks to meters and sensors, continuous monitoring of energy consumption is achieved, making it easier to identify areas where efficiency can be improved and unnecessary consumption reduced. But how can we be sure it's a reliable system that will work for our homes? How reliable is it? Well, a lot. Quick identification and response to outages. Smart grids can automatically detect faults and activate mechanisms to isolate and resolve the problem, reducing downtime, balancing supply and demand. Using advanced algorithms, smart grids can predict energy demand and adjust production accordingly, preventing overloading and blackouts. Integrate renewable energy sources. Smart grids can more efficiently manage the production and distribution of energy from variable sources such as solar and wind, providing a stable and reliable supply. The interesting thing is that there are different types of renewable energy that can take advantage of the smart grid system to become self-sufficient, such as management of variable production. Smart grids can adjust energy distribution based on the availability of renewable sources, such as solar and wind, which are intermittent. This means they can automatically alternate based on flow, situation, or state to maintain a constant energy connection. Energy storage. The system can store energy using batteries that store excess energy produced during periods of low demand for later use. This means there would never be any electrical waste, and we would have a system that would last twice as long in the long run. Ladies and gentlemen, I'm happy to say that this system is absolutely feasible because it has already been put into practice in some cities, such as Amsterdam Smart City in the Netherlands, with its project to integrate technologies into smart grids that aim at least to manage energy consumption and promote sustainability. By using real-time data to optimize energy consumption and implementing projects to motivate the city and its citizens to participate, similar to what is being done in the United States with Pacific Gas and Electric, and the implementation of advanced metering infrastructure, also known as AMI, which aims to manage detailed consumption data and facilitate demand response programs, or the KEPCO Smart Grid in South Korea, a national project within the country itself to improve energy security and savings, all within the framework of, but what is it exactly? Well, the system works through smart meters that transmit information about energy consumption in real time, both to consumers and to providers, to make better decisions about it, empowering customers to adapt everything to their own needs, creating a more transparent saving system. Thanks to this system, which is the basis of smart grids, providers can also better manage energy demand, giving consumers incentives to reduce consumption during peak demand periods. But there is a dilemma. It is necessary to take into account aspects such as the detailed organization of all of the above, and then to set up an installation system where the means, sensors, network actuators, and each device can coexist, requiring high investments just in the organization and having a good parity with renewable energy, such as solar panels and wind farms, to the smart grid, allowing a more efficient and sustainable energy management. This can lead to high budgets, as the initial investment in advanced technology and new equipment is significant. Infrastructure installation and deployment costs are also high. In addition, existing infrastructure must be upgraded or replaced, which can be costly and complex. The ongoing cost of operating, maintaining, and managing the smart grid must also be considered. This brings up some issues, such as technical complexity and parity, but also cybersecurity, since it's a digital system. The collection and transmission of detailed data on energy consumption is a sensitive issue in terms of consumer privacy and legal aspects, but it brings a host of long-term benefits. After the initial high costs, long-term energy savings would follow through cost optimization, and it would be a profitable investment over the years, thanks to the reduction of losses, allowing consumers to save by adjusting their consumption in response to dynamic prices. When it comes to emissions reduction, smart grids help improve energy efficiency and facilitate the integration of renewable energy, which inevitably supports clean and renewable energy, thus reducing greenhouse gas emissions. Despite the challenges, smart energy is emerging as a new or future technology system that is likely to become the solution to all current energy waste problems. If you like this video, don't forget to subscribe and hit that like button. See you next time!